This is EGR 101, Week 14, Part 2, What Discipline is of Interest? Hi, welcome back. So let's take a look at the various disciplines that you can study here at the University of Kentucky. The first one is Biosystems and Agricultural Engineering, BAE. This comes out of agricultural engineering, but has become much more. You can see here the multiple things in this slide that biosystems does. It's quite a broad area of study. It involves food, basically the production of food from the field through the processing plant through delivery to where we can get it. It also involves a heavy amount of environmental engineering. Biomedical engineering is a new one for the undergraduate curriculum at the University of Kentucky. It involves fundamentally two things: the design of medical devices, for example, infusion pumps that deliver fluids to people, or prosthetic medical devices, but it also involves the development of pharmaceuticals. So this has become a very interesting area of study, particularly in this time of this pandemic. Chemical engineering is a very broad topic. It uses the principles of chemistry to transform materials from one type to another. Chemical engineers, we think of refining, we think of petrochemicals, but they're also involved, again, in pharmaceuticals. They're involved in certain aspects of electrical production as well. Civil engineering was one of the two original areas of engineering. If I could go back several thousand years to the days of the Romans, let's say, I would find two types of engineers. I'd find military engineers designing fortifications and weapons, and I'd find civil engineers designing everything else, roads, bridges, aqueducts, buildings, etc. A very broad area, and it still is a very broad area of engineering. Environmental engineering is an aspect of civil, or it could be an aspect of biosystems as well. It involves, as the slide deck says, in the disposal, remediation, and prevention of contamination. Computer science is again a very broad area. It could be as focused as the embedded software that is right on top of the computer board that provides the glue that unites the computer hardware to the application code up above it. It could be all the way to large processing software that does what's called big data. Think of very huge databases where you're teasing out information from large data sets. Computer engineering and computer science are very related. I think of computer engineering as a blend of hardware and software. The computer engineers design the electrical hardware that is the computer board itself, but they also design the first level or first few levels of code that run on top of that. They're also involved in programmable devices called programmable array logic. This has become a very important part of many devices. Electrical engineering, another very broad topic. It can be as small as designing microelectronics, maybe laying out computer CPU chips to power plants, to large central station power plants, and really everything in between. Materials engineering, they will tell you that they're the foundation upon which everything else is built, and I kind of agree with them. The materials engineers understand why material behaves the way it does. They're also involved in developing new materials to meet needs. If I have a need for, let's say, a high temperature material and it doesn't currently exist, I might be consulting with the materials engineer to see what we can work out. Mechanical engineering is one of these other broad areas. It's split off from civil engineering around the mid-1700s when we began to develop the Industrial Revolution, primarily steam boilers, steam engines. The design and development of those things necessitated a different kind of engineering from civil, and mechanical split off. Now they're huge. They're involved in aircraft, automotive, printers, computers. Oh my gosh. Pretty much everything you can think of is, if it moves, it involves mechanical engineering. If it involves the translation of energy from one type to another, it probably involves mechanical engineering in some way. Mining engineering, they obviously work to extract raw materials from the earth, but they're also involved in turning those raw materials into usable metals, ores, etc., turning ores into usable metals. They're now involved in reprocessing and reclaiming from scrap materials, from waste materials. So, a quick reminder about the majors. Money, you have to do something that inspires you, and the money will come along, but the big thing is you have to do something that'll get you out the door in the morning. You can see from the discussion of the majors that we've had over the course of the semester that many majors do very similar work. Mechanical and civil might overlap in some area. Electrical might overlap with computer science and computer engineering. Think about that for a moment, that the majors do overlap, and if you can get a solid major right now, you can tape that in multiple directions in your career. So one question I want to leave you with before we go to the third video is, where do you see yourself? You could also ask this question, where do you not see yourself? I'm curious as to what you think. Please email me with your thoughts. Well, that's about it, and we're going to go to the third video here, so we'll see you in a little bit.